In this video, I'm going to be doing some more examples of integration using U-substitution. So the first thing that we always do is identify what U is. So in this case, U is equal to x plus 9. And we want to take the derivative of that. The derivative of U with respect to x in this case is just 1. So therefore, dx is simply equal to du. And in this case, n is -2. And so let's do our substitution. I'm going to put the -4 out in front. I like to put my variables out there, my constants out there, times the integral of x. And now x plus 9 is my u. So we have x times u raised to the -2 power, which is my n. So that's the -2 power. And then we take out dx and put in what dx is equal to, which is just plain du. So this looks really easy, du. However, there's a little bit of a catch in this problem. How do we get rid of that x? Normally we would have something underneath the du and the x's would cancel. But in this case, that's not going to happen. So we have to do something a little tricky here. We're going to go back to our u, which is x plus 9. And what we're going to do is we are going to say, okay, well, if u is equal to x plus 9, then x is equal to u minus 9 by simply taking the 9, subtracting it to the other side. Well, now that we know what x is in terms of u, we can substitute that into our problem. So we have -4 integral. Once again, we're going to take out the x and put in what x is equal to, u minus 9, in parentheses, times u to the -2 du. So now that we have everything in terms of u, we're good. So what we want to do is simplify this a little bit before we actually apply the power rule. So we have to multiply what's in the parentheses times u to the -2. So multiplying these two together, u to the first times u to the -2 is u to the, remember we're adding the exponent, so that would be u to the -1. And then minus 9u to the -2 by multiplying these two terms together. All of that times du. And you may want to rewrite this as 1 over u minus 9u to the -2. That might help you remember what rule we're going to use to actually integrate that. That would be the log rule. So actually doing our integrating now, -4 times the log of the absolute value of u minus 9 u to the -1 divided by -1 will just basically change that sign, plus c. And let's substitute back. -4 times the natural log of the absolute value of u, which is x plus 9, plus 9 over u to the -1 is the same as 9 divided by u. So that would be 9 divided by x plus 9 plus c. And so there is our final answer for this particular problem. Okay, let's do another one that is somewhat similar to that. And now this one also happens to be a definite integral. So that's a new twist on this particular problem. So again, we see that we have a composite function. My u is going to be this. So u is equal to 3x minus 6. Du dx, the derivative of that, is equal to 3. Or dx is equal to du divided by 3. And of course, my n is equal to 2. And I believe that's all I need. So I can rewrite this as the integral from 0 to 3 of 2x, and then 3x minus 6 becomes my u squared, and dx is du over 3. So we have du over 3. All right, so let's take the 2 and the 3 and move them outside. So we have 2/3 the integral of x u squared du. And let's not forget, this is a definite integral. We'll deal with that at the very end. Well, once again, we need to get rid of this x, and there's nothing underneath the du to cancel with it. So we have to do the same thing as the last problem. We're going to go to u and solve that for x. So I would have u plus 6 is equal to 3x, or x is equal to u plus 6 divided by 3, or I would say 1/3 u plus 2. So let's do some substitution. 2/3, the integral from 0 to 3. X is now 1/3 u plus 2 times u squared du. So we've got everything written in terms of u. What we need to do now is we need to multiply this by this. And so we will end up with 2/3 the integral from 0 to 3. Now 1/3 u times u squared is 1/3 u cubed. 2 times u squared would be 2u squared, all times du. Let's move over to the side here. Okay, now we can actually integrate. So let's go up here, integrate this. 2/3. So we're going to apply the power rule. I'm going to put this in brackets because 2/3 is being multiplied by all of this. So we're going to have 1/3 u to the 4th divided by 4 plus 2 u cubed divided by 3. And then all of that is going to be evaluated from 0 to 3, my bounds of integration. Put our vertical line there to represent that we're going to evaluate that using the fundamental theorem of calculus. But we got a little more cleaning up to do. So let's distribute this 2/3 times the 1/3 and then times this 2/3. So 2/3 times 1/3 is 2/9. Oh, and then we can, let me backtrack here a little bit. This 3 times this 3 times this 4. 3 times 3 is 9 times 4 is 36. We're going to multiply all these together in the denominator. So we have 2 over 36, which is 1 over 18. Let me just write it as 2 over 36 u to the 4th plus now the 2/3 times this 2/3 would be 4/9 u cubed, all evaluated from 0 to 3. But we've got to substitute the x's back in, and I can reduce 2 over 36 to 1 over 18 times, what was my u again? U was equal to 3x minus 6 to the 4th plus 4/9 times 3x minus 6 cubed, and all of that being evaluated from 0 to 3. So to evaluate this from 0 to 3, all we have to do is find f of 3 minus f of 0. And so remember, with a definite integral, with an indefinite integral, we are done when we find the antiderivative. This was the antiderivative. But now we need to evaluate that antiderivative at the upper bound, 3, and at the lower bound, 0, and subtract. So in a previous video, I showed you guys how to do that using Desmos, and it would be the exact same approach. So I would call all of this f of x, capital F of x, my antiderivative, put it into Desmos, and evaluate it. And you can go back and review that video on the fundamental theorem of calculus and definite integrals if you need to. Okay, and that will be it for this video.